So the equations for this section are going to be the same as they were in the last section, except acceleration is replaced with a g, and g is always negative 9.8. And instead of delta x, we're going to use delta y because we're going to be going up and down instead of left and right. This is section 2.1. So there should be 2.1 practice problems on Moodle. Okay. Number 1 says a stone is dropped from a cliff after it has fallen 10 meters. What is the stone's velocity? So what do we know in this problem? G is equal to negative 9.8. We know initial velocity since it's dropped is 0. Delta y is 10 meters. Is it going 10 meters up or 10 meters down? Down, so it should be negative 10. And what are we looking for in this problem? VF. So what equation are we going to use? Yep. So use VF squared equals VF squared plus 2g delta y. So looking for our final velocity. 0 plus 2 times negative 9.8 times delta y, which is negative 10. You gotta take the square root of that. So VF is equal to 14. No. G will always be negative 9.8. So 14 meters per second. Now, when you take the square root of something, what do you normally put in front of it in math class? Plus or minus. That still holds true in physics. Is this final velocity going up or down, though? Down. So we're going to make it negative 14. All right. Any questions on that one? Usually not, but the plus or minus is always there. So especially when you're worried about direction, you're going to need to keep track of it. All right. Number 2. A rock is thrown downward from the top of a cliff and there's a speed of 11 meters per second. If the rock hits the ground after 2.1 seconds, what is the height of the cliff? VO equals 11. It's turned downwards, so it's going to be negative 11. VO is negative 11, we said. VF is not 0. When we talk about the rock hitting like the end of this problem, like the final velocity, it's the velocity right before it hits the ground, not when it hits the ground. So G is negative 9.8, and we're finding delta y. So we can do our third equation up there that delta y equals VOT plus 1/2 GT squared. Substitute in there, we get negative 11 times 2.1 plus 1/2 negative 9.8 times 2.1 squared. And we get delta y equals negative 44.7 meters. And that's how far it fell. So it's asking for the height of the cliff, so technically you should write positive 44.7 meters because it's asking for the height, but I accept either of those two. We're really, unless it says something specific about constant velocity, don't use that one. So that will very, very rarely come up. All right. Harper? No. Either one of those would be fine. Either one would be fine. Like, I figure if you can figure out how far it fell, you can figure out the height of the cliff. Alright. Next one here. The ball is thrown upward and is caught at the same height 3.2 seconds later. What is the maximum height it reaches? So there's three things when something comes up and back down to the same height. First thing is the velocity at the highest point is 0. Other thing, if it comes up and back down to the same height, the time to go up equals the time to come back down. And last thing, the velocity it starts with equals the opposite of the velocity it finishes with for the whole trip. So we say, I'm not going to write that down. Just the velocity you throw it up with equals the velocity you catch it with in this problem. Does that make sense to everybody? There's 3.2 seconds, yes. If you're looking at the whole problem. In this one, though, we're going to want to do, we're looking for the maximum height, so we're looking for it at the highest point. So we're just going to want to consider the first half of it. Does that make sense to everybody? So for that first half, what do we know? df equals 0. We know g equals negative 9.8 meters per second squared. So t equals half of 3.2, so 1.6. So again, we're just considering this on the way up, and we're looking for delta y. Do we have any equations with just those variables in it? Nope. We're going to find VO first. So we'll use VF equals VO plus GT. Yeah, remember for free fall problems, G is always negative 9.8. So VO is what we're looking for, plus negative 9.8 times 1.6. So VO equals 15.68 meters per second. And now we can use any of those equations to find delta y. I'm going to use delta y equals VOT plus 1/2 g t squared. The velocity is 15.68 times time, which is still 1.6, plus 1/2, that's negative 9.8 times 1.6 squared. And you get delta y is 12.5 meters. That's the answer. Any questions on that one? All right. Last problem we'll do together here. Number 4. A falling stone takes 0.36 seconds to travel past a window that's 2.4 meters tall. What height above the top of the window did the stone drop? I should say drop. So it fall. It wasn't thrown down or anything like that. So what we have here is we have a window. And a stone that's dropped from up here falls past the window. This part right here took 0.36 seconds. We're going to have two parts of this problem. We're going to have an above the window part and then a part where it's at the window. So part 2 here is the part that takes 0.36 seconds. So what do we know about part 1 if it was dropped? That g is equals negative 9.8 meters per second squared. VO equals 0. And we're looking for delta y in this, but we don't have anything else. We're going to have to use something from part 2. The t is for part 2. So t is like how long it took to travel past the window. So for part 2, we've got T 0.36. We've got G equals negative 9.8 meters per second squared. And also know delta Y is negative 2.4 meters. So that's how tall the window is, so that's how far it falls during that amount of time. So what from part 2 would be useful to us in part 1? Not quite. What would the nope. Initial velocity for part 2 is the final velocity for part 1. Does that make sense to everybody? So if we find VO here, that'll be VF on the other side there. So we'll find VO there, and we're going to use delta Y equals VOT plus 1/2 GT squared. So delta Y is negative 2.4 equals VO times 0.36 plus 1/2 negative 9.8 is 0.36 squared. And we get, we'll check my math here. Everybody do that math. Okay. And we get delta Y, or VO equals negative 4.9 meters per second. So that's our final velocity over here. And then we use VF squared equals VO squared plus 2G delta Y. Negative 4.9 squared equals 0 plus 2 is negative 9.8 times delta Y. Okay, solve for delta Y. We get 1.23 meters, or negative 1.23 meters. So it fell from 1.23 meters above the window, or it fell negative 1.23 meters before it got to the window. Any questions on that one?